So welcome in this session. In this session, we are going to see the application of determination of maximum and minimum values to a business problem. So example. Example 2, and then business application. So business application. So this problem, a firm produces two kinds of commodities, so application. So here the problem, a firm produces two kinds so one that sells for $3 and one sold at cost of $2. And then the total revenue so it's in thousands. Thousands of dollars. From the sale of X thousand volts at 3 shillings, $3 each. And Y thousand and Y thousand at $2 shillings each. So given that 3 shillings each and Y thousand at $2 each is given by so the revenue cost or the revenue is X, Y is 3X plus 2Y. At the firm, determines that the total cost in thousands of producing X thousand of the $3 balls and Y thousand of the $2 balls is given by so cost function C of xy is 2x squared minus 2xy plus y squared and then minus 9x plus 6y plus 7. So this is a cost function. The question is to find how many balls of each type must be produced and sold in order to make maximum profit. So how many balls must be produced how many balls of each type must be produced and sold in order to maximize profit. So this still a problem testing on determination of maximum and minimum values. So the first thing that we have to understand is that to get profit, then the revenue must be more than the cost. So the first thing is to get the profit function. So solution. So we first get the profit function P of xy. I remember to get profit, then profit function is given by the revenue function minus the cost function. So profit is given by revenue minus the cost function. So which tells us that our profit function, our revenue is given by 3x plus 2y minus the cost function, which is 2x squared minus 2xy plus y squared minus 9x, and then plus 6y plus 7. And then so P of xy will be 3x plus 2y minus 2x squared plus 2xy minus y squared plus 9x minus 6y minus 7. So that our profit function on simplification will be minus 2x squared minus y squared y squared, and then so 3x so plus 9, okay, 11, 9 plus 3, that's 12, not 11. X, and then plus 2xy, and then minus 4y, then minus 7. So that's the profit function. So this is a function that we're going to maximize or minimize to get the desired solution. So next, find px, py, and then the r, we call it second derivative with respect to x, and then s is bp xy, and t will be p yy. So the role of f in the general definition is now taken by p. So px will be minus 4x plus 12 plus 2. And then really, so this is not 12, this is yeah, so that's fine. And then now p xx will be given by minus 4, and then py differentiate this with respect to y, so we have minus 2y plus 2x. So remember, so this is minus 4. So this is a y here. And then minus 4. And then pyy, we have minus 2. and then pxy. So differentiate this one with respect to x, you get 2. So those are the values. So px is minus 4x plus 2y plus 12. The pxx is minus 4. Py is minus 2y plus 2x minus 4. And then pyy is minus 2. And then pxy is positive 2. So so it's like this, like step 2. Step 1 is to get the profit function. Step 3 is to get the critical points or the stationary points. So set px equals to py equals to 0 to get stationary points. So this means that we'll have minus 4x plus 2y plus 12 equals to 0, and minus 2y plus 2x minus 4 equals to 0. So this is equation 1. This is equation 2. So equation 1 dividing through, actually we can add these two equations to solve for, to eliminate y, because y has positive sign in the first equation, and then negative sign in the second equation with the same coefficients. So adding these two will have minus 2x plus 8 equals to 0, which tells us that 2x equals to 8, and this implies that x equals to 4. Now using the first equation, so we'll have where the x put 4, so minus 4 into 4 plus 2y plus 12 equals to 0. Minus 4 by 4 is minus 16. So plus 12 plus 2y equals to 0. Minus 16 plus 12 is minus 4 plus 2y equals to 0. This implies 2y equals to 4, which implies y equals to 2. So therefore, our stationary point or our critical point is 4, 2. So AB is 4, 2. So the next step, step right now 4, or the other one was step 3, yes. Step 4, determination of RT minus S squared at this critical point 4, 2. And then the value of R from our calculation, remember this is what we call R, this is what we call T, and this is what we call S. Our R is minus 4, so R at 4, 2 remains to be minus 4. S at 4, 2. So the value of S from our calculation is given by 2. So when these are constant function, remains to be 2 throughout. So, and then T at 4, 2. So the value of t from our calculation here is -2. So it doesn't change. So therefore, this implies that RT minus S squared will be -4 -2 -2 squared. So this will be 8 minus 4, which is 4, and 4 is positive. So it tells us that the difference RT and S squared is positive. So i.e. RT minus S squared is positive. So when it's positive, it implies that a relative extremum or a extreme value exists. So since R is -4 and this is a negative value, then it tells us that the 0.42 must be maximum value. Then 42 then the 0.42 must be a maximum value. Or is i.e. 42 is a relative maximum point. So therefore, to maximize the profit, the firm must produce, remember the values are given in thousands, so must produce 4,000 of $3 balls and 2,000 of $2 balls. And the specific maximum profit, so P max will be given by replacing X for 4 and Y for 2 into the profit function, so which will be -2 4 squared, and then +2 4 and then 2, and then -2 squared plus 12 times 4, and then -4 times 2, and then -7. I'm simply replacing X for 4 and Y for 2 in the profit function that we obtained here, this function. So by doing that, I'll have, so this is 16, so this will be -32 plus 16 minus 4 plus 48 minus 8 minus 7. So I'll have 16 plus 48 minus 32 minus 4 minus 8 minus 7. 16 plus 48 minus 32 minus 4 minus 8 minus 7. That gives us 13. So this is 13. i.e. the maximum profit but all these values are given in thousands. So maximum profit is 13,000 dollars attained after producing 4,000 of $3 golf balls and 2,000 of the $2 golf balls. So that's how we solve such problem. So remember, in business, to get profit, then you simply get the difference between the revenue and cost. So revenue minus cost give the profit. So you get the profit function. After getting the profit function, then you find the derivatives of the profit function. After getting the derivatives, that's derivative with respect to x, derivative with respect to y, and then second derivatives. You set the first order derivatives to 0 to find the critical point. And then for this case, it's simply giving you the number of units of each item that you need to produce to get a profit. So once you set to 0 and then solve, you'll be able to get that stationary critical point. And then define the quantity RT minus S squared at that critical point. And then if it is positive, then it means that you are making a profit. So using the value of R and the value of this difference, you will be able to determine whether you are having a maximum or a minimum value. With that analysis, then you should be able now to get the exact profit value by replacing the values you obtain as your critical points into the profit function. And so this is how we solve the problem. So, thank you.